Hello, welcome to another class with Mathemasoft, and in today's class we shall continue with our topic quadratic equation. In today's class we want to look at how to find the vertex of a quadratic equation. So from the English perspective, what is the meaning of vertex? The word vertex can simply be referred to the top. Another word that is synonymous to vertex is peak, or the apex. So in other words, when we say the vertex of a quadratic equation or a quadratic curve, we are simply referring to the coordinates of the topmost point of a quadratic curve, or the peak point of a quadratic curve, or the apex point of a quadratic curve. This is what we mean by vertex of a quadratic equation. So let's go by the analysis. We already know that a quadratic curve can either be a U shape and it can be N shape. That is, either it opens up or it opens down. When the quadratic equation is a U shape, that is, it opens up, the point, which is the peak here, can only give us minimum points. Or let us say this place is minimum points, or we call it the vertex. And when the quadratic equation is an N-shaped graph like this, what we can get here as the point is our maximum point, or we still call it the vertex. In other words, the vertex of a quadratic equation can either be minimum point or maximum point. In the case of the graph opening up such that we have it in U shape, the vertex is otherwise known as minimum point. In the case of the graph opening down such that we have an N-shaped quadratic curve, the vertex in this case is otherwise known as maximum point. Let us take note that a point in this case means that there is going to be a y coordinate and x coordinate. In other words, the vertex is going to have an x coordinate and y coordinate in such a way that if we are to trace this, the x coordinate will be such like this and the y coordinate will be such like this. At this point, we are going to have the y coordinate of the vertex, and at this point, we are going to have x coordinate of the vertex, because this is the peak point. This is the topmost point on the curve, and this is where we call our vertex. And in this case, it is called minimum point. So either it is called minimum point or we call this vertex here. It's going to have its what? X coordinate and y coordinate like this. We can also trace the y coordinate of this maximum point to this place, and we can trace this down to x here. Now let us recall from our last lesson on line of symmetry. We said that a line that divides the curve into two equal parts is called line of symmetry. In other words, when you look at this line that cuts through the x-axis here, is the same thing as the line of symmetry, and this is also line of symmetry. In other words, the x value that we have here and the x value that we have here is actually our line of symmetry. So we can say line of symmetry, the value of the line of symmetry is the x coordinate of the vertex. I say that again. the value of the line of symmetry, which we know only has value on the x-axis, because line of symmetry only cuts the x-axis. So the value that you get for your line of symmetry is the x-coordinate of your vertex. Now we can also go back to the y-coordinate of the vertex. The point here at this peak here is called maximum value. Not point, but maximum value. And the point in this place can also be called minimum value. That is, the y-coordinate of the vertex can either be the maximum value of the curve or the minimum value of the curve. The maximum value can only be gotten on y-axis because that's the value that is traced to the y-axis from the peak, and that is why it is maximum value. In this case, it is not called maximum point. If we call it a point will have y coordinates and x coordinates. But in this case, it's just a value. Okay, we are just interested in the value of this peak, and that is why we say that what the value, which is the maximum value, can only be gotten on y-axis, and the minimum value in the case of U-shaped quadratic curve can only be gotten also on the y-axis. So we can conclude that the coordinate of the vertex, which can either be maximum point or minimum point, is given as line of symmetry, okay, which will be the x coordinate of the vertex, and the y coordinate of it can either be the minimum or maximum value of the quadratic curve. So your line of symmetry will give us the x coordinate of the vertex, and the minimum of maximum value, okay, here will give us the y coordinate of the vertex of a quadratic curve. So we have some quadratic equations here that we can use as an example in this case. Suppose we want to find the vertex of this quadratic equation. So let's give that a try as an example. We know that the vertex, or let's say example, what is the vertex of the quadratic equation y equals minus 6x squared plus 8x minus 5. So in this case, we are interested in knowing the vertex. And of course, because our a here is actually minus 6, we know that what this is going to be an N-shaped quadratic curve. And definitely the vertex in this case that we are looking for, because it's N-shaped, is going to be maximum point. So rather than this question being put like find the vertex of the quadratic equation, they can as well ask us to what? Find the maximum point of the quadratic equation. So in this question, if we are being asked to find the vertex, or we are being asked to find the what? Maximum point, they are actually what? Asking the same question. Because the vertex in this case is going to be the maximum point, because a is less than 0. A is less than 0 in this case. But that's not what we actually want to calculate. So here we are interested in knowing our vertex. And our vertex will be x coordinates and y coordinates. So to find our vertex, let's start with knowing our x. Since we know that our x will be the line of symmetry. And line of symmetry, because we have been given the equation, will be minus b over 2a as the formula. I hope you have seen the last video I uploaded on line of symmetry. We have actually done all this in that particular lesson. So please check if you have not seen the video. So from here, we know that our A is equals to minus 6 and our B is equals to 8. We don't need our C in this expression. We don't need to state out our C. But if you want to do that, you can state it out. So our X in this case will be minus B, which is what? 8 over 2 brackets. Our A is actually minus 6. And this will be minus 8 over minus 12. Minus cancel minus, 4 here 2, 4 here 3. So our X coordinate is going to be 2 over 3. Now that we have known our X coordinates, and we know that this entire equation is for Y. Y is equals to all this. So the value of Y, where X is equals to what? 2 over 3, will give us the Y coordinate. So for us to find our Y, we can say that Y equals minus 6 square, X square rather, plus 8X minus 5. And that will be minus 6 bracket 2 over 3 square, okay, substituting 2 over 3 for X, plus 8 bracket 2 over 3 minus 5, okay, and that will be minus 6 times 4 over 9, okay, plus 16 over 3 minus 5 over 1 equals 3 here 3, 3 here 2, and then that will give me minus 8 over 3 plus 16 over 3 minus 5 over 1, and that will be 3 as the LCM minus 8 plus 16 minus 15. Okay, this will be plus 1 minus 7, and that will be minus 7 over 3. So we can say, therefore, the vertex, which is X comma Y, in this case, is equals to X is 2 over 3, okay, and our Y, which is minus 7 over 3. So our vertex in this case, or the maximum point, occurs where we have X as 2 over 3 and Y as minus 7 over 3. In this case, if they ask you, we can say the maximum value, this case, it is maximum value, which will be your what? Y value, okay, is equals to minus 7 over 3. So the maximum value is equals to minus 7 over 3, although they did not ask us that. I'm just using that to make a difference between maximum point and maximum value. Maximum value is minus 7 over 3. Line of symmetry, you don't need to actually go for that. If they ask you to state the line of symmetry, you have gotten it, is 2 over 3. Line of symmetry is 2 over 3. But your vertex is 2 over 3 comma minus 7 over 3, or your maximum point is 2 over 3 comma minus 7 over 3. So this is how we go about finding the vertex of a quadratic equation with the approach of line of symmetry, okay, getting your line of symmetry, which is the X value, and substituting that in the entire what equation to get your Y, and then you state out your vertex or maximum point or minimum point. But vertex in the quadratic equation actually has its own form. There's a form we can write the vertex of a quadratic equation such that we can directly read out the vertex of the quadratic equation if the quadratic equation is being written in that form. And that's what we are going to do in the next video. I appreciate you for staying through in this video. Please share it out, like this video, comment to give me your feedback. Subscribe if you have not done so, and hit the notification bell if you have not done so that anytime I upload a new video, you can always be notified. Thank you for being on this video, and I wish you all the very best in your examination and in your academics. Please check the next video as we continue with the topic vertex of a quadratic equation. Bye for now.